So let's work through this example here. We're looking to evaluate y is equal to 1 upon the square root of 250. Now the correct answer is 0.063246. So we've got the input. The input is our value of x, which is 250. So this is x, which is 250. Now if we write 250 in 32-bit floating point representation, this is the number here. So the first one is the sign bit, which is positive. Then we have the exponent. Then we have the 23 bits for the mantissa. Now we're going to interpret this floating point number as a decimal, as an integer number. Now the integer number for this in hex is 437A0000, and whenever we write this in our integer, it's this number here. So this is our ix. Now the value for our mx here, we're going to start at this point here. So it's going to be 1 upon 2 plus 1 upon 4, 1 upon 8 plus 1 upon 16 plus 1 upon 64, which gives us 0.953125. So it means that our mx is going to be in the range 0.9 to 1. So that means that we've got all of the information we require in order to work out the value for our IY. So we know that if the m is in this range here, then from our table from a previous video, the value for our alpha is 0.7399. So in effect, this is the gradient of the approximation for our log to the base 2 1 plus mx. And we've got the value of beta, which is 0.2604, which this gives us the y-intercept of our approximation to the log to the base 2 1 plus mx. Our bias is 127, L is 2 to the 23, mx is this number here, which we've just worked out, and our value for ix is this number up here. Now if we put all of these into this equation here, we're going to get this here. So this is going to give us the final number here, which whenever we write it in hexadecimal is this number. So we can take this number here and put it directly in zeros and ones, okay? So this is it sitting in the values or zeros and ones, so it's just this converted to binary. And then we treat this number as a 32-bit floating point number. And we convert this 32-bit floating point number back into the decimal number, which gives us 0.0627937. So the number we're looking for is this number here, but we actually get this number here. So our percentage accuracy can be given by the number that we actually, the result that we get divided by what we're expecting to get times 100. And this is accurate to within 99.28%. So it does work, and it does give us a good accuracy for our first approximation to the inverse of the square root of the number 250. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.